This was one of the harder problems on the entire quiz, and the reason was that first you had to know from the one above what vertex form was, but then kind of think outside the box a little bit. Lots of you chose to factor this into x plus 4, x minus 2. If that were equal to 0, that means my zeros would be at 2 and negative 4. That's a great approach, but we still need to know where the vertex is. So if I look at something like this, I can see that halfway between my zeros would be my line of symmetry. Also, I think about those being the zeros and a positive leading coefficient, I know it opens up. I can also look at my equation and see that the y-intercept is down at 1, 2, 3, 4, 5, 6, 7, 8. So I can sort of start to connect these dots. Now I know that it's a standard quadratic, and so I go over 1, down 1, or up 1 from the vertex. So since I'm only one more away, I can see that I go over 1 and down 1 more to 9. A little bit of out-of-the-box thinking there. You could also say, hey, wait a minute. Now that I know my axis of symmetry is x equals negative 1, I could take that negative 1 and plug it into the original equation. Another way to find out that when x equals negative 1, y equals negative 9 at my vertex. Or you could have done the quadratic formula, the first part, negative b over 2a. That would also give you x equals negative 1. Lots of ways to find the axis of symmetry. From there the vertex comes out, and so now we can say y equals, well, I'm going 1 to 1 because I go up 1 over 1 and I go up over 3 up 9. So I know it's a standard quadratic with a positive leading coefficient. I know that I have x plus 1 because a negative 1 makes this term 0, and I'm down 9. That is how to find the vertex form of something in another form. Be careful, if on a retake or the next quiz this can't be factored, you can always just go right to the quadratic formula to figure out the axis of symmetry.